So sorry for keeping you so late. So don't worry, I'll be long. I have so many slides. No, I'll try to be on time. Okay, so as just said, I guess I have a pointer there. Yes. So I'm going to. So sorry for introducing a new organization, OGCI, that we have not spoken of so far. So as you can read from the flags below, the logos below, it's a group of 12 oil and gas companies that are trying to join forces in order to facilitate deployment of climate technological solutions, including CCS. So Owen is a very active member of this group, so he will. Happy to see you there. So I'll have 3 rapid slides of OGCI in general, and then I will go within CO2 storage, which is more the topic of today, this week, sorry. So again, we are 12 oil and gas companies. So you see we have our strategic pillars that are written there. It's about reducing methane emission and scaling up CCS, which is written in bold, and also other activity, all focus into climate solution, basically. And our 3 strategic pillars are towards net zero emissions, meaning as operator, we act in order to reduce our scope 1, scope 2 emissions and influence the operator should we not be the operator of an infrastructure or a site. Also leading the industry, meaning proposing other operators, not members, to apply the same technologies and helping to decarbonize the society, meaning promoting especially CCS. So if you go to our website, and this is the report of last year, you will see the number of projects in which we are currently involved. Each of these projects listed there is a project where either an OGCI member is the operator or is simply a partner. So you can, summing up these numbers, you have something like 40 projects. If I click on one, for example, Norway, then there will be the list of these 6 projects where you will find which of the 12 member companies are a member of this specific association, being eventually the operator, but not necessarily the operator. You will also find some case studies specifically about CCS. So this first one is about Brazil, activity of Petrobras of storing CO2 in saline aquifers. You will find, for example, another Northern Light joint venture that you're all familiar with, thanks to Renata. For example, activity from CNPC in China, activity from ExxonMobil in La Barge, and also to end up with a more local note, ENI Ravenna CCS project. Basically, it helps you identify eventually, gathering more information and also identifying contacts. So I will now jump into the storage component. So before jumping into it, we have various work streams. As you may understand, one is methane emission reduction, another one is CCS. And within this CCS work stream, we have a storage work group, so sorry for the many acronym, SWG. And basically, I will just show what are the type of activity we have conducted last year and completed last year, how to try to promote basically CCS. So the first topic will be the CO2 storage resource catalog that we've been working on. It's already something like a 5-year effort, so it's very significant. And we are helped by a Global CCS Institute in Halliburton for this purpose. And the idea is really to share knowledge about CO2 storage assessments globally, meaning that we collect, let me point on this one. So we collect assessment performed by others, meaning that we are not responsible or we're not owners of this assessment, but we try to collect all assessments that are available in the public literature, and we rank or classify the maturity of this assessment thanks to the SPE SRMS. I'll say a few words on this one. And the idea is really to bring transparency, clarity on where the CO2 storage resources assessments are, who did these assessments, meaning, of course, should you find a specific assessment in a specific country, you can click and have the full reference of the authors, which we are not, once again. So build confidence in estimated storage resources, a visual platform, and also promote the SPE CO2 storage resource management system. And I will come next slide on this one. Boop. Here it is, a few words on this SRMS system. So it's a 2-axis systems. So the horizontal axis which would be this axis here, is uncertainty. For example, in a box, you could have something between 100, 200, 400 million tons resources. And the vertical axis here is commerciality, meaning that we start with undiscovered or prospective resources. Then once all our data acquisition is complete, once we believe that we have the necessary data to proceed, then we go into what we call sub-commercial, when we are not yet ready to invest because more modeling, because eventually we have dossiers to complete, permitting, etc. And finally, once basically we are ready to proceed and to invest, we label this commercial or capacity. Okay? So a very important point on this resource assessment is that it is a project-based system, meaning that if someone tells you, I believe I can store 120 million tons in this saline aquifer or depleted reservoir or wherever, that person should say, what is the type of infrastructure that would be needed to inject these 120 million tons? What is the type of CO2 migration that is expected? And what is the type of pressure buildup that is expected? So basically, it's to say there are studies at a certain level of maturity, not necessarily investable, but studies that say that a project with a given infrastructure, number of wells, for example, or pipeline versus ships, would be able to inject these numbers. And the good news, thanks to Serge Van Hessel, so sorry I can't see you right now, but over there. So it is now an aligned system to the UNFC. So a bridging document was adopted in Geneva end of last month in order to align the the UNFC injection project system with the SRMS. So so what is this catalog? So here you see an image of what we produce if you go to our website. And of course, you can click on every single dot to know what's behind this dot. So some learnings, because we just produced this just for fun. We hope it makes sense, and we hope some people use this type of information, of course, is that some countries still have no CO2 storage resources, no publicly available assessment. The global resources are vast, so the table there indicates the scale of the resources that are published. So you see that capacity, meaning investable resources, are very small, less than 2 gigaton as published. Sub-commercial capacity with advanced studies, I would say, advanced development study, are pretty high, eventually 675 gigatons, and prospective resources are 14,300 gigatons. But the important point is that you may know that my table has 2 columns, because we face this issue of eventually overestimation of resources. Some authors indicating, oh, you could certainly store 3 gigatons, but nobody knows how you would ever be in a position to store 3 gigatons. So for this purpose, whenever we analyze CO2 storage resource assessments, we tick whether it is project-based, which it should be under SRMS, or not. And when limiting this table to the project-defined or project-based resources, unfortunately, we see much smaller numbers, meaning that only 130 gigatons within this catalog, for only 130 gigatons, the evaluators, the authors, made the effort to indicate which infrastructure would eventually make it and whether the pressure would be acceptable by the formations typically. Another important learning is that CO2 storage storage efficiency range in saline aquifer is still very poorly documented, and this is the terrible histogram you see here. So you see that the storage efficiency for various assessments. So storage efficiency, is the fraction of the pore volume that you can use to locate CO2. So if you read a store that indicates 10 to 15%, it means that eventually the author considered that you could extract 10% of the water and replace it with 10% of CO2 somehow. And you see that this range is super high. You have eventually 2 decades, a factor of 100, depending if you are an optimistic evaluator or pessimistic evaluator. And we believe it's really something that collectively we should work on in order to provide clarity to decision makers, to regulators, to even emitters. Okay, so another delivery from last year was the mafic rock map that was developed together with Carpstrat. It was already presented at EHE GET last year. Basically, it was about evaluating this basalt storage or mafic, ultramafic rock storage globally. And a few findings are, I believe, very relevant. First is that mafic, ultramafic rock can be not present at the same same location as sedimentary basins, so they can be complementary in the solution. Another important thing, I believe, is that eventually mineralization is nice, but it's not a requisite of CO2 storage. It's a plus. You will feel better if all the CO2 you have injected is indeed mineralized, transformed into carbonate rock. But it's not a necessity, so it's important to remind. Also, the before last bullet point is that currently all injecting CO2 project into basalt rock inject CO2 dissolved within water, meaning that you may have to inject 20 or 30 times more volume because it's CO2 dissolved in water than should you inject only CO2, meaning a much stronger pressure response eventually. And if your resource is in volume, then 20 times less storage resources because it will be occupied by water eventually. And also the fact, and this is the last bullet point, is that as no significant scales mafic, ultramafic storage has ever been implemented so far, it's difficult to know what's the global resources because we don't know how these systems will behave on the middle to long term. So now I will move to the long-term liabilities and risk profiles for CCS projects. Basically, the starting point is that, and this work was performed by DNV and was shared with CCS and presented to insurers. So this is the Geneva Association that was mentioned by Juho earlier, in order to gain confidence in investability and explain how we can define, especially how to insure CCS projects. So in the literature, the main risk profile is the one from Sally Benson, a great CCS person, as you know, from Stanford. She published this profile in 2007 and was updated in 2014. And this is how it looks. So you start at the very start of this image. Zero risk because there is zero CO2. The more CO2, the more risk, of course. It makes sense. If it leaks, the bigger the leakage can be. Also, the risk increases because pressure increases. So at the end of injection, you have the maximum risk, and then pressure dissipates, CO2 dissolves, etc. Lives get better, and eventually the risk will decrease. So the problem is that the message is that the risk will be maximum in 25 years. Do you want to invest in this one? Today it's safe, but the risk will be maximum in 25 years. So it's not a very sexy message for an investor or for an insurance company. So basically, the message we want to convey here, or the change of narrative, is saying, okay, indeed there is a risk that is evaluated prior to injection, which is the dotted, is it a green or a yellow? Well, green line there, corresponding to the orange line of Sally, basically. Okay, we start knowing that we will face this risk during the lifetime of our CCS project. If it's too high, we will eventually acquire more data, change our monitoring technology, etc. And then when we start injecting, we're going to monitor, and it comes back to the presentation of Elodie at the first workshop. And this monitoring will help us take decisions. Either the risk do not materialize. For example, the risk was CO2 will go west, and we observe that CO2 goes east. Risk decreased. Or the risk materializes, like on Snøhvit Thibeau, suddenly pressure gets too high, then we take decision and we reperforate, redrill, and we remediate by anticipated solution in order, in the both situations, to decrease the risk, to make sure that at the end of the injection, thanks to all the knowledge we have gained and all the remediation measures we have implemented, the risk is much lower than the risk we faced at the beginning of the project. So basically, this is typically the type of discussions we have with insurers, and of course we receive feedback and we exchange our mutual understanding in order to help understanding what we should work on. So another, I hope I'm not too long, no, it's okay still. Some actions that we are pursuing for this year. One is the promotion of the SRMS for resource reporting, and again, this ties very much with this total versus dynamic resources versus prospective versus whatever, however you call it. We believe for clarity with an investor or with a regulator, it's important to have a single name, and that this name should be shared and understood by eventually the public, for example. And SRMS is a tool, as well as UNFC, to go in that direction. So promoting storage efficiency workshops between members in order to eventually develop guidelines or methods how to apply them. And also expanding the CO2 storage catalog in so far unassessed countries. And this is it for me.